Which of the following is our resonance structures of CH2N2, which is diazomethane? Students, in this question we are given with 3 resonating structures and we have to identify that which is the resonating structure of diazomethane. So it is very clear, all the 3 structures given are the canonical structures of diazomethane. That means the resonating structures of CH2N2. So the correct answer for this question is number 4. That means structure number A, B and C all represents the resonating structures of CH2N2. So the correct answer for this question is option number 4. Moving to next question, students, which is 82. If x-axis is internuclear axis, then pair of orbitals which on overlapping form pi bond is. The options are px, py. Students, px and py results in no bond formation. Moving to next, dxy and dxy. This results in pi bond formation. Moving to next, px and px. Hence, x is the internuclear axis, so this results in sigma bond formation. Moving to next, px and pz. This also results in no bond formation. That means the correct answer is number 2. That means the overlap of dxy and dxy results in the formation of pi bond. So the correct answer is option number 2. Moving to next question, students, which is question number 83. Orbital involved in the hybridization of XeF4 are. Students, let's find out the hybridization of xenon in XeF4. Since xenon has 4 bond pairs and 2 lone pairs, so hybridization is sp3d2 and the orbitals involved in the hybridization is s plus px, py and pz and dx square, y square and dz square. That means the correct answer for this question is option number 3. S, px, py, pz, dx square, y square and dz square. So the correct answer is option number 3. Moving to next question, students, which is 84. XeF2 has same shape as I3 minus, H2O, SO2 or I3 plus. So student, here we have to draw the structures of the given compound, starting with XeF2. In XeF2, xenon has 3 lone pairs and 2 bond pairs. So the shape is linear. The next is I3 minus. In this case also, the central iodine has 3 lone pairs and 2 bond pairs. So the shape is linear. Moving to next option, which is H2O. In this case, oxygen has 2 lone pairs and 2 bond pairs. So the geometry is bent. Moving to next option, which is SO2. In this case, sulfur has 1 lone pair and 2 bond pairs. So the geometry is bent. Moving to last option, which is I3 plus. I has 2 lone pairs and 2 bond pairs. So the geometry is also bent. So it is very clear that XeF2 has same shape as I3 minus, that means linear shape. So the correct answer for this question is option number 1. Moving to next question, students, which is 85. Molecule which does not have both polar and non-polar bonds is. The options are H2O2, the next is Cl2O, the next is S2Cl2 and the last is P2H4. So students, let's draw the structures and then we'll be able to find out that which compound does not have both polar and non-polar bonds. Starting with H2O2. The structure of H2O2 is, this is a polar bond and this is a non-polar bond. Moving to next option, which is Cl2O. In this case, oxygen is the central atom and chlorine are the surrounding atoms. Both the bonds are polar bonds. Moving to next option, which is S2Cl2. So SSCl. Here these two bonds are polar bonds and the central bond is the non-polar bond. Moving to next option, which is P2H4. P2H4. Here 4 bonds are polar bonds and 1 bond is a non-polar bond. So the only compound among the given option which has only polar bond, that means does not have both polar and non-polar bonds, is Cl2O. So the correct answer for this question is option number 2. Moving to next question, students, which is 86.